This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gregory Kapfhammer. Today's guest is Itamar Friedman. He's the CEO and co-founder of CodiumAI. Itamar and his team develop a whole bunch of cool automated testing tools, and they use generative AI techniques like large language models. Itamar, welcome to the show.
Hey, very nice being here. Thank you so much for inviting me.
We're glad to talk to you today about an open source tool that you've developed at CodiumAI called Cover Agent. Cover Agent is based on a paper that was published at the Foundations of Software Engineering conference. Let's start by exploring some of the features that Cover Agent provides and how it works. Are you ready to dive in?
Yeah, of course.
Okay, so at the start, I'm going to read a quotation that comes from the documentation for the Cover Agent tool, and then we're going to use this sentence to explore more about how the tool works. So the sentence is as follows. It says, CodiumAI Cover Agent aims to efficiently increase code coverage by automatically generating qualified tests to enhance existing test suites. So let's start. At a high level, can you explain what are the testing tasks that Cover Agent automatically performs?
Yeah. So I guess you're mainly referring to types of testing, like is it unit testing, component testing, integration testing, etc. So basically, I think the Cover Agent can try to generate all of these. But the sweet spot that we saw is mostly around component testing. If you provide an initial few tests that cover one or more components and you run Cover Agent, it will try to generate many more. Actually, it will try to generate as many as it could until reaching your criteria. Like, for example, until a certain threshold was met or a certain iteration that you define that you don't want to run more than a few iterations because there's also a cost that comes together. Basically, what Cover Agent does, it takes the first few tests that was given as part of the test suite and is exploiting these to inspire it to generate more. So if you will come with integration test or end-to-end tests of different types, it could be like end-to-end tests in Playwright or Cypress, etc., it will try to mimic that. If you come with a few simple component tests, it will try to mimic that, integration test, etc. So you can aim and try to generate any type of testing. Having said that, it works the best for component testing at the moment, like with the current implementation, July 24.
So you said it works best with component testing. When you say component, is that equivalent to talking about unit testing?
Yes, like the reason I prefer the term component because I think it makes it clear that you can do more than 4 lines of code, than what you expect from a simple method or something like that. If you're doing clean code, of course. And if you have, for example, a class that could have 500 lines of code with just an example, like 5 methods, actually, I think you will be more happy or will be more satisfied running Cover Agent on that. Because it's within the limit of Cover Agent from what we see technically and experimenting with it empirically to generate good tests for this kind of setup. And I think that provides more value. Of course, it's a matter of taste and also situation. Some people, they have better appetite for specific methods like unit tests because for different reasons, they want them to be fast. They want to verify that each specific method is being highly tested, or some would prefer like going one level above, like which is a component. In many cases, you gain a lot of the properties of unit tests. They're still fast, they're still like independent and things like that, but you have more opportunities for interesting, behaviors that are capturing more of what the software is supposed to do. So I believe that component testing is the way to go, and Cover Agent covers that quite nicely, so that's why it's our recommendation. But you can go with unit tests as well, considering our terminology, of course.
Okay, thanks for that response. It was really helpful. Now, just a moment ago, you mentioned this idea of increasing code coverage. Can you talk briefly, what is code coverage in the context of Cover Agent, and why is it a good idea to increase code coverage?
Right. So code coverage in the most simple terminology is considering a test suite and considering a set of files, method, classes, packages you want to cover. You want to check how much of the lines, we'll come back to this notion, how many of these lines are being covered by the test suite. So just an example, let's say you have a test suite of including 5 tests, and you have 2 files with each one have 2 components, and each one has 100 lines. Okay, so 400 lines. You want to check, like the coverage report will tell you how many of these 500 lines are being covered by these 5 tests. It could also tell you like a breakdown. In most cases, like depends on the package that you're using to create the coverage report. In most cases, like it will tell you like each method or each package or each file, like the coverage of that specific component, a specific item. And then lastly, I want to say that we did talk about like line coverage. When I explained myself, I talked about line coverage, like how many lines are covered. That's like the basic metric here. But there are other types of coverage. For example, there could be branch coverage. Branch coverage, there could be others, but just as an example, branch coverage means how well we're covering each one of the branches in the code. For example, an if statement could have 2 branches, and you could, in line coverage, if you pass this if statement, great, +1. But in branch coverage, you want to check if you passed 0, then it's 0% of this line, 1, then it's 50%, or 2 of the options of this branch, then it's 100%. By the way, an if statement could have as many as statement, it could not only 1 or 2. And that's really interesting. The reason I want to double click on the branch coverage, because I think like there's a huge, it was really hard to work with branch coverage, but actually LLM opens opportunity to work with branch coverage for 2 reasons. First, sometimes a LLM can help you describe branch coverage in natural language description. Like sometimes it's like hard to say like which part of the branch, if it's a large if statement, which part of it, how are you passing it? LLM can help you describe it in natural language description. And the second thing is like usually to pass through each one of the branches, it's really hard to generate those type of tests, and we probably cover it a bit later. And LLM can help also on that.
Thanks for that response. You mentioned things about LLMs, and we're going to dive into how Cover Agent uses LLMs later in our discussion. You talked about code coverage, and you mentioned branch coverage and statement coverage. Both of those sound like higher is better metrics, where getting more code coverage is better than less. Is that the right way to think of it?
Many would say that code coverage is a proxy metric. I think almost 100% people would say that. But I think that also some percentage of developers and managers would say that code coverage is actually a vanity metric. Practically, what we're trying to say is that did we check that the code worked exactly as expected? Okay. And now, how do you check that? Supposedly, you have a spec. And if the spec describes any possible usage of your code, basically, you can try to convert this spec into like tests comprehensively, like one-to-one, like fully complete translate of your spec into tests. And then who cares about what's the line coverage? Rather, you actually tested all the options. I'm not talking only like when I'm saying like 100% spec specification, I'm also talking about like edge cases and bad cases, anything that could eventually happen to your software, any data processing, any software runtime that can happen. So who cares about line coverage? The question is, can you write that kind of spec? Can you simulate that kind of situation? And in most cases, and even in the harshest, like on the hardware, where it's maybe even simpler, in the case of military or space where you really want to, it's still very hard. And then the question, what's your alternative? So if you can say that you covered 100% of the lines, then you're probably in a good place proxy-wise, because you probably like pass through all the options or a lot of the options. Having said that, I just gave an example where maybe you passed through some if statement, and maybe this if statement leads you to the next line, but it could lead you there in many different ways. And probably you want to check each one of them if you want to like perfectionize your testing. And then you want to go like different types of branch coverage and statement coverage, like things that you mentioned. But even then, it could be a proxy and even like vanity. But I think these days, nobody until today invented something better. So the higher is better because you probably tested more statement, more use cases, more flows of your software. Having said that, I think there's opportunities for LLM also to change that, but that's like a different answer. So I'll wait a second. And just to finalize, I want to say that there are other metrics. Like, for example, there is the mutation testing metric, but I think most of them, the industry, the standard will say that are complementary to code coverage.
Okay, that's really helpful. So you've mentioned statement coverage and branch coverage. And I think the intuition there is if you don't cover the code, you'll never know whether or not there was a bug in the code because you didn't run it in the first place. Is that the right way to think about code coverage?
Yeah, I agree. Like basically, okay, maybe back to fundamentals. Code coverage is in most cases not being measured or tested or reported with some semantic analysis like symbolic execution or something like that. It's usually being measured by actually running a test, that actually running the code of the test, and that actually eventually, or it could be like running the test doesn't have to be code. Like if it's integration testing, etc., it might be like API calls or something like with a script or with some UI. But eventually it means running the test that actually makes your software run. And then, right, it's a simple way to say it. Like if you checked each line, if you checked a specific line, hence you ran the software such that this line is being executed, you decrease the chance that that line has a bug. But, it actually doesn't really like necessarily say that. Let me give you an example. A test is usually, it's composed of like, what is the data you want to run through your software? And then could be some logic for manipulating your software or manipulating the data, and then receiving the output of your software and then checking that output. Basically, you can do a mistake and do really bad like checks. And practically the line was executed of the line of the code that you want to check was executed. Hence the coverage report will say done, clear, but you didn't really test it. Let me give you an example. Let's say I'm writing a test of a sort function and I'm writing like, here is an array and I'm running the array and 1, 2, 4, 3, and I'm getting back the result and I'm checking that the array is like, I'm doing a property-based testing, which is not bad. And I'm checking that the output of the sort is 4. The length is 4, right? And the sort function might bring me back 1, 2, 2, 2. It's not the right accurate. The test coverage could be even 100% or close to it. And it's not working and we're all like happy, but no, the sort function doesn't work. So the fact that we pass through a line is not enough. So although you describe really like simply, I think like it's a bit more complicated. And that's why coverage is also complicated. And people say it's like sometimes proxy or vanity.
Yeah, that was a great response. So I think what you're saying is that coverage is a proxy. It's helpful, but it can't be the final answer. Now, let's turn a little bit to the coverage agent implementation.
Yeah.
So where does coverage agent come into play in the story that you were just telling about testing a sorting algorithm?
Great. So in many ways, I won't double click on or explain all and let's chat. So first, writing tests and thinking about happy paths and edge cases is a tedious task. Like if you want to get to above 80% code coverage, even in a simple like method, I'm not saying that this is what you need to do. It's not my call to action, but go to ChatGPT and ask for, give me some, snake game or whatever, more than 100 lines of code, but not to more than that. And then try to start generating tests that will, cover more than 80%. It could be quite challenging. So it's a tedious task to think about everything. So first, you can use Cover Agent. First, you need to come up yourself with a few tests. And then, like after, probably that will be quite easy, just thinking about a few simple tests. It could be even a couple. And then the first thing that Cover Agent will help you is generate a bunch of tests. If you give it a good prompt, sometimes even without prompting it, there is a prompt option. It's aiming to generate edge cases and like complementary tests and help you think about your testing. Eventually, by the way, although a test suite is supposed to reach to high code coverage, you can choose not to take all the tests and like you just shorten your time to think about those tests and think about those edge cases. And then like, okay, these two seem too simple. These two I don't like because, there's some test smells. There's code smell, but there's still test smells, etc. By the way, a shameless plug, if you need to generate this few first tests and you're also either lazy or want to use AI for that, that's one of our other tools like CodiumAI ID plugin for VS Code or JetBrains. It's called CodiumAI, by the way, the ID plugin. It helps you exactly with this a few tests. That's one point that I mentioned, like just help you with more edge cases, etc. But ideally, Cover Agent would have the right frameworks and prompting and guardrails also to help you with the quality. I just talked about test smells. So if we are expecting AI to be, being able to like using AI, using LLMs to kind of guide us not to fall into pitfalls, not to do like bad practices. Actually, I don't know if you noticed, like OpenAI just released Critic GPT. It's specialized, like supposed to be specialized in that. We also have similar models in CodiumAI specializing in finding smells and problem, etc. And then if you're not, the top testing engineer, developer, or you're just tired and this mistake could cost you, then Cover Agent supposedly it's still a tool that needs to be worked on, to be frank, but supposedly to also help you to apply best practices. So these are two examples why using Cover Agent.
Okay, that was really helpful. Thanks for telling us those details about Coverage Agent. One of the things that I'm taking from our conversation so far is that you're still expecting the software engineer to be in the loop, so to speak, when these test cases are being generated. So they can guide the Cover Agent tool, they can accept some of the tests and reject other tests, and then they can iteratively pursue the generation of test cases. Is that the right way to think about it?
Yes, actually, I would like to, in high level, talk about examples that this tool would work quite well. And I'm talking about well with respect to can it, with a click of a button, generate a full test suite, a good one, and cases that it won't. And actually, like if you just expect it to, with a click of a button, give you a good test suite, it just won't. Okay. And this debate will actually lead to a point where I believe that we are quite far, at least with the current implementation of Cover Agent from, you need the developer in the loop and it will stay like that for a long while. And this might lead to when not, I think the profession will evolve, but that's another question. So great. So I claim that sometimes 4 lines of code, like in clean code, 1 method, like there's a very, very high chance that you will find these exact or very similar 4 lines of code somewhere in some open source, even if you think they're special. And by the way, a plus or a minus might be a big difference, but very, very similar, if not 100%. Like we think we're special. I think like software becomes special in 2 ways. One is how we start combining like these methods of the 4 lines together. And sometimes like just 1 minus or 1 plus or something like that makes a difference. Okay, why did I mention that? Practically, if you are doing like a small component testing, and these components are relatively simple, they take like simple strings, simple integers, simple structures, and manipulate them in ways that you expect to have in the open source, even if it's sophisticated like types of manipulation, you'll be surprised sometimes. You will feel, oh my God, I just wrote 2 tests, I called Cover Agent, I got 100% good coverage. I actually did it 3 times with a different prompt. I got 3 different test suites. And the future will also integrate mutation testing, etc. So even tell you which of the 3 test suites are better. We just talked about cover report not being like good enough and you need to complement it. So, and then like, oh my God, you don't need me. Okay. But although, by the way, notice that I did say that you need to come with like 1 or 2 first tests. And even in those cases, we can talk about it later if you want me to. But in cases where your code actually is strongly coupled to unique data that is unique for your company, is unique for, for your software. Let's say, you're some kind of like entertainment company and you have like a special JSON. Don't hate me if that's the structure that I'm using now to run through my software. And let's say you have some JSON that comes from a database and you keep throwing into different parts of your software to actually like execute what your business logic you're trying to achieve. If you don't collect it by yourself and use that part to prompt the Cover Agent, it has a very low chance to actually being able to do any proper testing. Now, by the way, I want to challenge myself. Supposedly, you can say that a lot of this JSON structure and data could be covered from the code. If we're talking about regression tests, and we didn't talk about it right away. We are talking about regression tests right now. So because there are if statements, there are different like string matching, etc. So you could supposedly, if you're intelligent like creature, the most intelligent creature, you can infer those like structure, etc. But first, LLM are not sufficiently intelligent right now. And I do claim that there will be many cases that you cannot infer everything from the code. And if you even try to, it might open a too large like space to actually do proper testing. So one reason, just as an example, why you can't avoid right now from working with the developers is that the developers need to provide additional information extracted from the databases, extracted from your Jira ticket, from your specification and whatever, and prompt the cover agent. And then let the hard work of like the tedious work of, writing like different edge cases according to that to the cover agent. And I claim that just collecting these data, it's not like such a simple task. You need to know which data you want to collect and why, etc. So we're still being challenged, but I think this is, in my opinion, the fun part of the testing, like thinking what is the type of the data I need? Maybe because I'm an ML dude in my past, ML professional. So like thinking what is the data I want to provide the cover agent to be able to generate tests for me. I think that's actually where the creativity and fun generating tests.
That makes a lot of sense. So you've mentioned that these large language models are helping the tester to augment their existing test cases. Are the LLMs running on the tester's computer, or are you leveraging some type of cloud-based service that provides the LLM to the tester who's using Cover Agent?
Great. So we try to provide a tool that is generic to the LLM. It's hard, by the way. You will notice like that different prompts could benefit from getting better results, not just in Cover Agent, anywhere from different models, but we tried to be very generic as much as we could. And we connected like the light LLM like package, the library, it's open source. And that enables the user, if you're the developer, if you download our tool from GitHub or pip install, etc., to basically choose the model. Now, interestingly, the model right now is like almost light LLM supports almost any cloud models. But I actually think, and I'm not like you a bit of like change my confidence, but I think that light LLM also supports like local models. And if not, I believe that integrating Ollama, for example, is quite easy to do. So just open us in the Cover Agent GitHub. Hey, I couldn't run it locally. And probably quite quickly, we will integrate like Ollama or something. So any cloud model, although you might need to play and see what works better for you, I think also local. And if not, we'll make it local. It's not an issue. Quality will be different. Okay. Like this is life. Like smaller models at the moment are less good and usually use smaller models on your computer.
So when I tried the tool called Cover Agent, I was able to integrate with a whole bunch of different cloud-based LLMs. And we did use Light LLM when I was trying out the tool. And we'll talk about that later in our episode. Just to be very clear, when I'm doing code coverage testing with Cover Agent, is it transmitting my code to the LLM that I have picked using the Light LLM system? And if so, what kind of code does Cover Agent transmit to the cloud?
Yeah, totally. In order to provide good context for the LLM, what is given is the existing test suite, the coverage report to some extent, and also the code that we want to cover. The LLM will provide much better results. Like one of the mode of operation for Cover Agent is to generate tests that cover lines that are not yet covered in order to increase the code coverage. Therefore, the code needs to be sent to the LLM provider in order to see those lines and the context around them as much as possible to actually was helpful in most cases in order to pass through this branch. So definitely the code and the existing tests would be beneficial. That's what Cover Agent does, as well as like the coverage report or like data that is extracted from the coverage report.
All right, so the Light LLM tool helps Cover Agent interact with a whole bunch of different cloud-based models.
Right.
You can also use it with some local models, and it's going to transmit a part of the existing test suite and maybe the project source code. so that it can generate new test cases that augment the test suite. Now, I think at this point, we've mentioned that there are a whole bunch of cloud LLMs like ChatGPT or Claude or GitHub Copilot. Before we move into some of the specifics about the implementation of Cover Agent and then how you actually evaluated it, can you briefly compare it to things like Anthropic's Claude or GitHub Copilot or other tools of that nature?
Yeah, of course. Okay, so with your permission, I'll really shortly talk about like Alpha Codium. It's another open source tool that we provided that you can, with a click of a button, generate solutions for code contest competition, like for competitive code competition, and do better than the majority of the competitors there. And that's like amazing. And if you just try GPT-4 or Sonnet 3.5, etc., and prompt them, even use the best prompt you can, you won't reach even like half of the accuracy that you would reach with Alpha Codium. And the reason is that Alpha Codium is more an agentic, or if you like, what we call a flow. It's like a specific agentic methodology that is designed to generate solution for, simple competitive programming problems. And within this flow, we try to inject the best practices that you would do as a developer. So it's like built-in guardrails and best practices that you won't see like out of the box, like ChatGPT or Claude AI actually applying. That's why you get the best result there. And now apply the same notion to Cover Agent. We're trying to work with this design a flow, or actually Meta did it right in their paper to perfectionize for this task.
Is the idea then that somehow Cover Agent is collecting information from the product's code base and then making the right kinds of prompts so that I, as a software engineer, don't have to figure out how to do that when I'm chatting with GitHub Copilot or Claude or some other system like that?
Yeah, right. There's a slight, like, still as an engineer, there's something inaccurate there and I'm going to fix it, but it's correct. So before I'm fixing it, you're right. Like, you are going to use Cover Agent by stating, here are the components I want to cover. Here's how I would run the test suite and the coverage report. And, there's a few more like parameters, like what the coverage I want to achieve. And then the Cover Agent would definitely do some context collection that basically would not happen easily with those tools that we just mentioned. But also the second part is that it will start a flow that will not happen, but maybe by chance it will happen with Claude. There is some agentic flow, but there's higher chances that a flow that's designed to increase code coverage, generate test, Cover Agent will do that for you. The only inaccuracy is that the context collection from your repo right now in Cover Agent is relatively basic. And that's one of the, opportunities to improve. It's much more elaborated than there's no context collection or relevant one in ChatGPT or Claude, but here it is, but it's still basic as opposed to other tools of ours like the ID agent or the PR agent.
Before we move on to the next topic, can you give a concrete example of the flow that you had been referencing a moment ago?
The Alpha Codium one or the Cover Agent one?
You could describe it in either Cover Agent or Alpha Codium, because I know they're both tools to help software engineers by using LLMs. But let's start with Cover Agent. What is the flow that you were referencing?
Okay. So when we came out with Alpha Codium, we coined a term like flow engineering, which was actually accepted by the industry, if I may say, like Andrej Karpathy, etc. What we're saying there is that usually how we perceive AI-empowered system is what I call like system one thinking, system one systems. I'm referring to Daniel Kahneman, unfortunately not with us for passed away like eight months ago or so. It's basically like you give the system a prompt, like a request. The system collects some context, like immediate context. And with one inference, we provide the output. And that's like what's prompt engineering about. Even RUG is almost like that. Like it's just like a more sophisticated part of context on the collection. And system two thinking, like the system, it's not just an inference, is running a full flow that could have 2 to like infinite amount of like prompts, usually not, just to give you like a dozen of prompting. And we'll also use some tools. Okay. And this flow is not just like a chain of thought, or like the React, if you're familiar, that just gives the LLM the full freedom to compute, infer by itself what's the next step. Rather, it's like almost a state machine. That's why I'm calling it a flow, with edges, and each node you say what that task needs to be done. And flow engineering is designing that flow. And then, interestingly, it happens that the prompt, the variance of the accuracy of the system, because changes in the prompt, actually reduces. When you're doing only system one thinking and not system two, with system two is the full elaborated system flow, then small changes in prompts could generate really big differences in the output. You probably have experienced that. But if you're doing flow engineering, a lot of the information and like intelligence is the flow itself, and usually the prompts are simpler, etc. In Alpha Codium, we put it simple. I'm not going to elaborate too much right now. Is we basically designed a flow that imitates the developer. Here's a problem given as an input. As a developer, you would reflect on that, try to understand it, try to think how would you test like the solution. Then think about a few solutions. Try to think which is the first you want to try to implement. Try to think how would you test that specific one. Then implement it. Then check it versus test and fix it. Generate a few more tests, fix that, and then output. That's exactly, by the way, the Alpha Codium flow in a very simple way to description. That's the flow Alpha Codium. The cover agent flow is very different. To put it really simple, here's a few test suite. Parse the coverage report. Try to inference which are the lines you want to now cover to enhance the coverage. Try to generate a few tests. Each test, check, does it run? Does it pass? And does it increase coverage? Yes, take that test. Rerun the coverage report and iterate. Okay, that's a full flow, like putting it in a simple way.
Wow, that was really helpful. That makes a lot of sense, and I think it is a good foundation for us to dive into more details. Now, we've already mentioned Light LLM, and I think we get that that helps the Cover Agent tool work with 100+ large language models. I wanted to briefly talk about the tool that's called Pydantic, because I noticed that Cover Agent uses Pydantic, and I think that Pydantic may play a role in flow engineering. So can you tell us briefly, what is Pydantic, and how does it work in the Cover Agent tool?
Yeah, in the most simple way, I think like Pydantic, it helps you to manage typing. Like Python is not inherently like very good with types as opposed to some other languages. And sometimes it's extremely helpful that when you pass data to a different method, function, etc., like you ensure that the parameter, the variable, etc., like receives the input with a certain style and a certain format, aka a certain type. Pydantic helps you manage that in different ways. And you're right that if we designed a prompt to fit for a specific structure, and now like if you ruin it in the middle, maybe the entire flow would be ruined. Rather, if you kind of stop the flow because of a typing problem, or you fix the type on the way, you probably still, in many cases, get a good result. So that's like definitely like kind of the guardrail, like an example of a tool that you can integrate into flows to guardrail the flow.
That makes a lot of sense. And just to make sure that listeners are clear, the Cover Agent system itself is built in Python, and many of the packages that we're talking about are connected to the Python programming language, although Pydantic is actually now at its core implemented in Rust. I think at this point, Itamar, it might be helpful if we very quickly comment on the types of programs for which Cover Agent can generate tests. If Cover Agent is implemented in Python, does it only work for Python, or can it generate code for programs in a wide variety of other languages?
Great. So this time I'm going to simplify with my answer, and then I'm going to fix myself just to keep it simple at the beginning. So Cover Agent itself is written in Python, but the LLM is the one that's generating the code. And your command that you provide as an input to run that test, to run your environment, to run your code, is the one that actually like needs to be in your language, etc. So there's no theoretical implication or constraints about which language you want to apply Cover Agent on, like programming language, except that maybe if this language is too exotic that the LLMs were not trained on that. But like I mentioned, we did design a flow, and it includes different prompting, and certain prompts try to deal with different flavors of testing types, testing properties. Like, for example, in Python, you need to have this indentation, right? And in other languages, there are others like, you need to have a setup method in some cases and of different kinds. And Go is specific about its style, etc. And sometimes the LLM will not output proper tests, and the entire idea of cover agents is automatically generating those tests, running them, checking them. So you need the LLM to output proper tests to start with. And then you need to have the prompt that guides the LLM with different properties. And it could be that different languages would have higher accuracy, less faulty tests, etc. For example, we mostly checked on Go and Python and TypeScript, JavaScript, so probably will do really well there. I think the next language, Java, we tried really well. Last thing, and that's the end, you do need a coverage report, and part of Cover Agent is parsing the coverage report. Okay, so that's also kind of language report, LCOV, Jokaka, sometimes that's a funny name, I don't say correctly, etc. And so basically, that's another limitation. It's not a real problem. Like if you don't see one of the coverage tools there, you can actually go to the open source and try to write a parser. So there's no a real limitation, rather like a current status of the implementation. I think we're covering LCOV, Yokako, etc. There's 3, 4, one of them. Okay, so that's another limitation that can be overcome really easily.
That makes a lot of sense. And in fact, it connects to my experience with using Cover Agent. So when I was using it to test some of my own Python code, I gave it a coverage report in the Kobatura XML format. And lo and behold, it parsed it perfectly. And it was able to generate test cases for my project that did, in fact, increase coverage. So the idea is, if I'm understanding you correctly, Cover Agent itself doesn't have a coverage tool inside of it. It leverages existing coverage tools that can produce coverage reports in existing well-known formats, like the one that comes from Kobatura or Jacoco or other tools of that nature. Am I thinking about it the right way?
Yes, correct. Kobatura is exactly one of our favorites, for example, for Python, etc. And Jacoco is definitely the leading ones, but you probably might have your own preference that you're using in the company, and you're probably going to be running them, for example, as part of your CI/CD, part of your build when you want to check that your build is right now passing all tests or whatever process that you have. We definitely didn't want to create our own coverage tool and coverage report. Rather, we wanted to connect to yours, because you probably already, if you care about testing and that's why you're coming to Cover Agent, then you're probably already using one of these tools, and we prefer to connect to them. So you won't need to change anything, and this tool will be useful for you.
Sure, that makes a lot of sense. Now, a moment ago, I remember you talking about how it could generate code for a Python project or maybe a Go project. And in the context of Python, the LLM might actually generate a test case that isn't formatted correctly. Or in Go, it might generate a Go test that doesn't compile. So what does Cover Agent do in those tricky situations?
Yeah, great. So the first thing that Cover Agent does in order to validate a test is actually check if it runs, compiles, etc. And the most basic implementation of Cover Agent would just drop that test. A bit more sophisticated implementation of Cover Agent would take the output from the log, from the error, message, and can try to regenerate and fix that. Why am I saying with that confidence? Because we do have this fix mechanism in our other tool called CodiumAI, but in Cover Agent, maybe until you publish it or already be there. But first, we wanted to reproduce the result as much as we could from the original paper, and that doesn't include that mechanism. Right now, if it doesn't build, run, compile, we don't take it. But obviously, the more comprehensive solution would be to take a look on the automatically have Cover Agent fetching the error messages and try to fix. You could claim that maybe it's not the best way to go because who said that eventually, runtime wise and cost wise, it's worthwhile to look on the error. But in my opinion, it is at least some kind of one of the routes to explore, because if it didn't run, if it didn't compile, actually maybe there is some gold to dig there to fix that and reach a new branch, a new line to cover, etc.
Yeah, that's a really good point, and it connects to something that I was thinking about. So in addition to a test case not compiling, or perhaps not being formatted correctly in the context of Python and PyTest, it may be that the test case is failing. So does Cover Agent distinguish between a test case that is failing because it found a bug and a test case that was failing because it wasn't set up correctly or something like that?
Yeah. Okay. So right now, Cover Agent, similar to the paper that it tried to reproduce, is only doing regression test. And this is very valuable. For example, let's assume that you're an agile team developing a lot of code and you don't have time to create regression tests. At some point, usually there are builds that you have very high confidence about them. So much quicker than you would imagine, you can generate a lot of regression tests, and then moving forward, you would know if you're breaking something or not. So regression tests, although their value is limited, in certain cases, it could be like invaluable. Now, considering that we're focusing on regression tests, if a test pass, like we do want it. That's a short answer. Having said that, it's tricky. A test can actually pass if like the logic is bad and the code is bad. And the tests can pass if the logic is bad, but actually the assert we talked about in the beginning, what checks if the result is right, is bad. So actually it's very tricky. And this is like different technology can be applied to try to prove that actually there are fields and areas. It's not just 2 and 2. It's not bad code, bad test, good test, and things like that. Actually, it opens up to a whole new world of what's a bad test, bad assert, bad logic, bad data. So it could be like a lot of problems there, but the most simple implementation right now is regression test. And considering that we did proper prompting, and if it passes, we want it. By the way, that's also one of the reasons you want a human reviewer at the end to like what we talked about in the beginning.
Wow, that's a really good response, and I see exactly what you're getting at. And clearly, generating test cases or augmenting a test suite automatically is a really tricky task to get exactly right, because sometimes test cases may be passing, but for coincidental reasons. And in other cases, they may be failing, but if you're going to focus on regression testing, ideally you want to confirm the existing behavior and you want to increase coverage when possible. Is that the right idea?
Yes.
Okay, good. Now, one of the things that I think about when I'm writing my own test cases is that sometimes I have to write mock objects. Does Cover Agent actually generate these various types of mocks or spies? Overall, can Cover Agent make test scaffolding for me?
I would say that mocks is one of the most challenging parts. Like I think that also what you hinted, like with proper testing, because there's you want a test to be fast and they're not flaky and things like that. But there's also a problem with mocks. Maybe it's not like proper testing of your real production case, etc. It's really, really challenging. Okay, that's a side note. Why I think it is important. Right now, specifically for Cover Agent, I'm not talking about our other agents, mocks are treated very simple, so in a simple way. If you provided mocks as part of your simple test suite, they would be considered. Otherwise, you need to, in most cases, I'm not saying it's still AI, a statistical creature, it might generate mocks, although it's not being prompted to that. But in most cases, if you didn't provide it as part of your like original small test suite that you're trying to enhance, then you need to provide a proper prompt. Like although Cover Agent is a tool and a flow and not a Q&A, there's still a mechanism, actually two mechanisms to prompt a Cover Agent. One is by providing additional data and files, etc. We talk about part of the reasoning for that. For example, if you actually want to provide like data that is expected, like because your software is complicated and the input is coming from some database or something that the LLM won't be able to think of. And the other is like more a traditional, it's weird to say traditional, but more traditional prompting. And we managed to inject that into a flow and not the Q&A. So you can use these two mechanisms to try to influence Cover Agent to create mocks, because the default is kind of off. And it might do a good job, relatively speaking, comparing to, and we need to say to compare to what, but to tools that are professional in generating mocks, maybe not as good, but comparing to like a simple like ChatGPT or something like that.
Before we move on to the categorization of tests that Cover Agent may generate, I remember that a moment ago you talked about something called a flaky test. So
Yeah.
briefly, can you tell the listeners what is a flaky test? And then how does Cover Agent handle flaky test cases that may be returned by the large language model?
This time I'm going to give an example to explain what is a flaky test. If you have a test and you're running it 5 times and it doesn't give you the same result each time, especially if sometimes it passes, sometimes it fails, that's the most obvious flakiness, then it's flaky. It means how can you trust that test if it passed 4 times, the same test? Just run it 5 times and pass 4 times and fail 1. That's a flaky test. LLMs, you can try to prompt it not to generate a flaky test. Actually, I think the prompting to start with will try to do that, because there are test smells that can be smelled. For example, if there is an obvious API call, an obvious one, if the API fails, let's say, like I'm going to take the simplest, again, example here, like you're calling like an exchange API from dollars to euro or something like that, and that could be flaky. Then you're flaking your test for no reason. And that's like an ideal place. For example, in my opinion, there could be exceptional reason to put a mock, for example. So like LLM will try to help you with that if you prompt it, but there's a lot of responsibility still on the developer to run Cover Agent on components that, or in a way that to start with, like checking independent components or independent microservices, etc., to reduce the flakiness. And again, another responsibility yet for the developer.
Okay, so it sounds like down the road, Cover Agent might be able to do things like rerun the test suite or look at deltas of coverage or things of that nature. But in part, it still is the responsibility of the software engineer to think carefully about which components they ask Cover Agent to test, and then to look at the test cases and to assess whether they're good ones or not.
Correct. I'm not saying that in 5 years or so, there won't be systems that will take more and more parts. For example, a full code analysis of your code base, and then suggesting you as a developer, here are 5 areas, 5 components and 2 microservices and 1 end-to-end system that we recommend you to run A, B, C, D tools. One of them is a Cover Agent. And then you're almost like orchestrator, etc. And that will come with an analysis of which part of your code base would probably be less flaky and also very important to test, etc. But right now, I think although at CodiumAI we are developing things like that, they're not as mature developers are being needed. Again, like I just hinted that even in 5 years being needed, but right now they're needed for different reasons, more fundamental stuff like you just mentioned.
Of course, what you're saying definitely makes sense, and it connects to my experiences with Codium and also with Cover Agent. One of the things that I wanted to briefly touch on is that when Cover Agent was creating tests for me automatically, I noticed that it would categorize the tests as like a happy path test or an exception test. And I didn't do that. The tool did it for me automatically. So what are those types of tests, and how does the tool actually categorize them in that way?
Okay. We talk about code coverage, right? We talked about the fact that if you cover more lines of your code, that is, you ran tests that executed a certain line, then you probably have the lower chance to that you have a bug and that run through that line. That means that if you want to cover 100% of the line, just an example, we talked about the problem with this metric, cover 100 lines. Also, you need to have the right assert, etc. I'm going to repeat that. It's important. Then you would want to go over many different behaviors of your code, many different edge cases, etc. And the part of the flow and the prompting, flow engineering we did, and the prompt engineering we did in Cover Agent, and that's only going to be enhanced as we progress through time and techniques that tries to generate, these happy paths, edge cases, etc., to cover more and more parts, more lines, etc. And I think developers appreciate when the thinking of an agent is being exposed, that you notice those properties, and and because we said that, for example, developers need to review the output, it helps you to review it more easily. By the way, when I'm talking about flow engineering, for example, what I mentioned, for example, in order to catch not only more edge cases, but strong edge cases, I might want to run mutation testing and other tools. Okay, so that's and we will output, Codium Cover Agent will output some of these, so you could be amazed, engaged, and make it easier for you to review the output.
So I think this is the second or third time that you've mentioned mutation testing. My impression is that it's not yet integrated into Cover
Right.
Agent. But to make sure our episode is now self-contained, can you briefly talk about what it is and then what steps you might take to integrate mutation testing into Cover Agent?
Yeah. By the way, I love to do that. And maybe that's a good call to action. We open source Cover Agent and you can use it and we'll be happy. And we do have a lot of contribution, by the way, from the community, like single developers as well as like companies, etc. I want to encourage everyone here to contribute. And I think one of those, especially for professionals that worked with mutation testing, that's one of those contributions we'll love to see, that we provided a roadmap. There are different types of mutation testing. I am going to simplify a bit, although it's hard for me not to be accurate. I probably wasn't accurate many places to simplify things. I'm going to do that again here. Roughly speaking, there are two types of mutations. Given a test suite and given a code you want to test, you can, type 1, mutate the test. Type 2, mutate the code. Let's talk about type 2. Let's say I have a test suite that supposedly cover 85% of the lines. And let's say I have a second test suite that also cover 80% of the lines. How do I know which test suite is better? It could be that they're even covering the same lines, but they're very different tests. Actually, could be different tests. Mutation testing type 2, the one that mutates the code, could help. If let's start with something simple, randomly mutate the code, and the test suite is not failing, like let's say you start with all the tests are passing, and the test suite does not fail any test, the tests are probably, let's say mutate a lot, the test suite is probably not strong. The test suite that actually fails more tests as I mutate the code is probably stronger because it's catching more of the code. Notice a few hyperparameters here. Do I randomly mutate the code? How many mutation I'm doing? Which type of mutation? These are part of the thing that in the past we would do heuristically with some algorithms, and actually LLMs is one of those. LLMs can help us improve performance on that part. I believe you can imagine what's type 1. It's different. Like here you mutate the test. I'll stop here. Let me know if to double click on that.
Okay, thanks for that description of mutation testing. I'm sure that will be helpful to the listeners. As we start to draw our episode to a conclusion, I want to let them know that they should check the show notes, because in the show notes, we'll reference the Foundations of Software Engineering paper that was published by researchers and engineers at Meta that was ultimately the inspiration for building the Cover Agent tool. What I want to do now is briefly turn our attention to some of the lessons that we've learned today. So, for example, we've talked about automated test augmentation. We've talked about the role that the large language model should play in this process. And I'm wondering, can you share a little bit about some of the lessons that you have learned when you've been building Cover Agent or the Alpha Codium system or some of the other commercial products that are coming out of CodiumAI? What have you learned about developer productivity and building good developer tools?
Great. So I'll shortly relate to one learning around building those tools and one learning about using developers' productivity tools. So about developing them, there could be it's a talk by itself, but I do want to iterate on the flow engineering. Don't try to build a tool that all it does, quote unquote, a prompt, collect context, prompt, and LLM output. Try to build a full system that evolves like an algorithm, a flow that includes guardrails and inject best practices that fits for what you are building. Okay, and that creates higher accuracy, and results, as well as lower variance, either of the system or of your prompt that you're injecting. And by the way, I think this also projects to any other tool that you're using with AI. Okay, try to think about flows when you're building a tool for physician or for lawyers or etc. About dev tools, I think like developers love writing code. They love building. And now they can, use code completion to do even a bit more. Probably save time and go drink more coffee. I don't think it's really helpful for generating more features. But actually, let's think about the real bottlenecks. I don't think it's writing more lines of code. It's about code quality. It's about code reviewing. It's about testing, etc. So I think that when you want to start integrating, different AI dev tools to improve your productivity, actually think what are your today bottlenecks and what are your today problems. For example, if you look on your, sprint and you see 50% of your task is bug solving, do you really think that adding code completion will help you to deal with that? Probably you need to find how AI tools can be injected into your workflow to reduce the amount of bugs, to reduce the quality, etc. So that's my main suggestion. Don't think about the tools. Think about your pains and problems, and then search for the existing tools to try to solve that.
Wow, this has been an awesome conversation, and what you said a moment ago was really thought-provoking. If listeners want to learn more about some of the things that we've talked about today, like GitHub Copilot, they can refer to episode 533 of Software Engineering Radio. I'll also link you to some other episodes where we've covered some affiliated concepts. But with those points in mind, now that we've talked about Alpha Codium and Cover Agent, and you've given us a call to action, is there anything that we haven't yet covered that you'd like to share?
I just want to say that I really enjoyed very detailed discussion about the Cover Agent, and that what I want to encourage people is to play with these kinds of tools. Play with them. Like the profession, I'm not saying it's going to evolve tomorrow, but it's going to evolve. Try downloading these tools, playing with them. Like Cover Agent is literally like 1 minute to run. And you will notice that there is one part that is hard to actually navigate, is that command that you need to provide to Cover Agent on how you want your test to run in your environment. Because the idea that Cover Agent needs to run in the environment where the component needs to run, and then it will take you 15 more minutes, okay? You probably have that environment to some extent. And then like with an hour, you don't stop yourself. Try these kind of tool like Cover Agent, and do that, in my opinion, weekly, because some of them like suddenly going to have like leapfrog like effect. And you want to have those in your arsenal as a developer. Everyone, all developers, I think are going to be AI-empowered developers in the very near future.
Yeah, that's a great point. I want to emphasize for our listeners that you can download the Cover Agent tool from GitHub, and I tried it out, and Itamar, I have to agree, it was super fun. I tried it with a whole bunch of different LLMs. I tried it on different projects. I tried it for different languages, and it was super cool to see it generating all of those test cases for me, and in some cases, I could integrate them into my existing test suite. So let me say thank you for this conversation. And additionally, let me say thank you for open sourcing the Cover Agent tool. It's been a lot of fun for me to try it, and it's been great for me to chat with you today. Is there anything else you'd like to pass along to our listeners before we conclude the episode?
No, thank you so much.
Well, thank you for talking today. This is Gregory Kapfhammer signing off for Software Engineering Radio. Goodbye, everyone.
Thank you, Gregory.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.